The differentiator circuit, it is also one of the important application of the op-amp. In this case, the output is differentiating the input voltage, or the output is given by differentiating the input voltage with the time constant RF and C. And here Vin is connected or applied to the negative terminal of the op-amp. So we are getting the negative of Vout. The remaining, the positive terminal is connected to ground level. So when Vin is applied, the current ion is flowing through the capacitor C. That capacitor becomes charging condition and get some voltage across the capacitor, that is V of C. At the same time, the same amount of current also flowing through the feedback path, that is through feedback resistance, that is IF. Then we get a sufficient Vout voltage in the form of differentiation of the input voltage. And one more thing, whatever the voltage at the node X is equal to voltage at node Y. So now the voltage at node Y is 0 volt, so that the V of X is equal to V of Y is equal to 0 volt. So now come to the derivation part. In the derivation part, In is equal to IF. So whatever the current, input current is flowing through the capacitor C, the same amount of current is flowing through the feedback resistance also. So in this case, we need to find or write the equation of two current equation. One is In and IF, and here IF is given by minus Vout divided by RF. According to the Ohm's law, IF is equal to minus V0 by RF. And consider at the input side, Q is equal to C into Vin. Q is the charge, the capacitor into Vin. When you take the differentiation of this equation, dq by dt is equal to C into dVin by dt. Next, another current equation of In. So this current is flowing through the capacitor C, is given by C into dVin by dt. C into dVin by dt. And when the In and IF currents are equating, so we get minus V0 by RF is equal to C into dVin by dt. Then from this equation, we can get the Vout is equal to minus RF C into dVin by dt. Okay, so whatever the minus Vout by RF according to the circuit diagram, so this current IF is equal to minus Vout by RF. Actually, the IF equation is IF is equal to Vx minus of minus V0, but Vx is equal to 0 volt according to the virtual ground concept. Then C into dV in by dt. This is in current. So in is equal to this capacitor C differentiation of dV in by dt. So when equating both equations, we are getting this output voltage in the form of differentiation of V in with the time constant Rf into C.